The first page is just the name and the date or the pledge, yeah, and then jump right into it.
Well, see if I can blow this up. I can't. I don't seem to be able to, but I don't think I need to. Take a picture of it. You want to start at 1?
Yeah, let's do that.
So, expected value is, how do I explain it? It's the product of all possibilities. So,
Okay.
it's the product of that, the product of that, the product of that, and the product of that. Now,
Okay.
make sure that's correct. Probability of x equals x. So the probability of 0 is 0.5. So if we do 0.5 times 0 plus 0.3 times 1 plus 0.15 times 2 plus 0.05 times 3. Well, that goes to 0. So we get 0.3 plus 0.3 plus 0.15. That all equals to 0.75. That's the expected value of x.
So you're basically multiplying, and then you're multiplying each.
Yes. Multiplying
Okay.
each one and then adding all 4 of those.
It's kind of similar to like averaging. You get to do it all. And
A little bit, yeah. Expected value is a little strange in how you do it.
Okay, let's do number 2.
Okay. What expected value does is it gives you a way to calculate whether or not you have a plus or minus edge in a game. Let's say you go to Vegas and you decide to play roulette. Expected value tells you what you're going to lose on every single bet. The average.
Mm-hmm.
Same if you play blackjack or games like that. There are no games in Vegas that have a positive expected value. Now, blackjack can be argued that it has a positive expected value because the odds tend to change on every deal. So blackjack's the only game in Vegas that offers you a possible positive expected value.
What about Texas Hold'em?
That's different. That is not a game where you're playing against the house. But I have lots of experience in Texas Hold'em. Okay? That's a game where you're really playing against the other players at the table.
Oh, yeah.
And the house only takes a rake of each pot.
Uh-huh.
So, yeah, you can beat Texas Hold'em, but you have to be considerably better than the average player at the table. In other words, if you're average ability at the table, then your expected value is going to be whatever they rake the pot. If you're the best player at the table, then your expected value might actually be greater than their average rake of the pot, which means you might actually have an expected value that's positive. And that for sure happens. There are players that win month in and month out in Vegas
Okay.
playing No Limit Hold'em. It's
Okay,
all about how you play, how you're, well, there's a really important thing in Texas Hold'em, okay? If you are the 10th best player in the world, and you're playing in a game that has the top 9 players, then you're a dog. You do not have a positive expected value, even though you're the 10th best player in the world.
Well, even with that kind of, in that kind of situation, like, it's mostly just card luck because most of the players are pretty close, right?
I mean, yes and no. There's a lot of luck in poker, but
Yeah.
there's a lot of skill also. I mean,
Okay, listen.
I actually had months where I never had a losing month, ever. And, so skill tends to outreign luck, but you can never get away from the luck factor. And, you know, there's always a finite probability that you will hit a streak that, you know, I said, what's the odds? If I flip a coin, what's the odds that I'm going to flip heads 10 times in a row? What's 1,000 to 1? But that means every 1,000 times it can happen once. Doesn't mean impossible.
Let's do this because I got a test tomorrow. I'm sorry.
Well, it's something to consider whenever you're in a gambling type situation where expected value is what you're going on. It does not matter what your expected value is. You can still go broke. And there's a lot of probability involved in what kind of bankroll you need versus what your expected value on each proposition is and that kind of stuff. All right, let's go on to the next one. Wow. How are you getting such hard problems?
You know what?
Dominic. What?
You want to hear something interesting?
Yeah.
My last test, we went over it. It was the one where we were both a little confused about the questions, you know?
Yeah.
I actually ended up getting a 42. One of the top students ended up getting like a 56. The highest grade was a 78 by someone who normally doesn't do too well, but I guess he did really good on that one. But yeah, the grades were absolutely horrible.
Well, this is a different math topic for sure. When you're talking probability and statistics and stuff like that. So let's look at number 2. Okay? After you draw a ball out of the bag, you place it back before your next draw. If you pull a ball out of the bag 100 times, how many times do you expect to draw a red ball? Well, what's the probability that your first draw draws a red ball?
10 out of 50.
1 out of 5.
Oh, yeah. Yeah.
Okay? So, if you pull a ball out of a bag 100 times, how many times do you expect to draw a red ball? Oh, that's relatively easy. What's the answer?
500. I mean, wait. No. Wait, what? Wait. Oh, 20. 20.
There you go. There you go.
Yeah. I don't know what I was like looking into it way too hard.
Yeah, that's the answer. And that's problem is not as tough as it looked.
Yeah. Tries to confuse you. Let's just go to the next page and see what's going on.
Okay. Let's see, the next page. Oh, man, I'm sorry. Hold on.
Okay.
Closed out my Gmail. Didn't mean to do that. pages does this have? How many problems are
5.
there?
There's 5 pages.
5 pages? Okay.
Yeah.
You tell me
The
what
first
problem you want to go to.
Okay. Well, let's do 6 and 7, I guess.
Okay.
I think. Oh, this is sequences. Okay. Yeah, we can do 6. I'm pretty sure I get it though.
Okay. Make sure you know how to do it.
Mm-hmm.
So what kind of sequence is this? Is this arithmetic or geometric or neither?
Arithmetic. Wait, no. Geometric.
Correct.
Wait. Yeah, geometric.
Why? Because
the 64 to 100 is different. Right?
actually it's not even geometric.
Oh no, even it's the 16 and 36 and the 64 and the 100.
For it to be arithmetic, the difference in every term would
it has to be the same. Yeah, that's what I mean.
That disqualifies it immediately.
Mm-hmm.
For it to be geometric, the ratio has to be the same.
Oh, so it's neither.
Right. 16 divided by 4 is 4, but 36 divided by 16 is like 2 and change. So you're right, it's neither.
Yeah. Well,
Now,
okay.
what else does it say? If arithmetic give the difference, if geometric give the ratio, neither show why.
It's because they're different. They don't have the same ratio or the same.
Because it's neither arithmetic or geometric. So that's why it's neither. In other words, it's easy enough to prove that it's not arithmetic, and it's very easy to prove that it's not geometric.
Okay, let's do 7.
Okay? What kind of ratio or sequence is this?
Is it
Here's the way to figure it out, Dominic. What's the difference between those first two terms?
negative? It's -3. Like,
Well, hold on.
I mean, no, positive 3.
Plus 16. In other words,
it's,
first thing we're going to do is to see whether it's arithmetic. Okay?
Yeah. No, it's not.
Next term is minus 48. So immediately it's not arithmetic. Okay? So now let's see if there's a common ratio. So take that term and divide it by that term. What do you get?
-3, right?
Now take the next term and divide it by that term.
Yep.
That tells you it's geometric.
Geometry, yeah. I thought so. Okay, we can move on. I get these. They're pretty easy.
All right.
Straightforward. So page 4, I guess.
Well, this next one,
It's a little hard. Let's do it. Why not?
this sequence, the instructions are a little strange. They tell you it's either arithmetic, geometric, or neither, and explain why if neither. Well, to me, then the only thing you have to do is prove it's not arithmetic and not geometric, and that makes it neither. So, in number 8, if I thought it might be arithmetic, that immediately proves it's not arithmetic. And if I try to prove it's geometric, I get 4 to 1 compared to 9 over 4. So it's definitely neither. They do not ask you to spell out what kind of a power sequence this would be.
What would it be?
Well, it would be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. In other words, it would be this.
What is that?
Well, you're not familiar with the sigma notation?
I might have heard it
Well,
before. But
notice what this says. Sigma means the sum of. Now, granted this is a sequence, but more important than sequences are series. Series means the sum of a sequence.
Mm-hmm.
Well, the first term here would be n equal to 1. So that would be 1. Second term would be n equal to 2. 2 squared is 4. Third term, n equal 3. 3 squared is 9. You can see that what we have written will produce that sequence, that exact sequence that we're looking at. And if nothing else, this shows you that sequences and series are not just arithmetic or geometric. They can be all kinds of things. In fact, one of the hardest topics of calculus is infinite series, and even trying to figure out whether they converge or diverge. But the fact is that that is that sequence, and I can write it in the way that I wrote it.
I don't think he's asking us to do that, though.
No, he isn't. If neither, you must show why. Well, I don't think he means this, because you haven't gotten to this yet.
I think he just means like do the work to show that you tried both arithmetic.
No, it's not arithmetic and it's not geometric.
Yeah.
That's all you have to do.
Okay, let's see the next page.
Okay. Well, let me take a look at this one. This is separated by 2, 3, 4, 5. So again, this is kind of a sequence. What would the next term of number 9 be?
It would be 2. Oh, it'd be 21.
Yeah. Okay. So that's neither arithmetic nor geometric, and you can certainly prove that it's neither of those. So that makes it neither. That's all you have to do to show why. But we can also see that it's an interesting sequence in the sense that we can predict the next term and the next term after that.
Mm-hmm.
You buy a new car. Let's let X equal the price of the new car. What's the price 1 year later?
X times 0.05.
Oh, that's how much it depreciates. So
Yeah.
if you bought a new car for $100, it would depreciate by $5 per year. So at the end of 1 year, it would be $95, right?
Yeah.
So what it really is 0.95 of X. You buy a $10,000 new car, it's going to be worth $9,500 at the end of 1 year.
And how many years does it want us to write it out?
Well, I don't know.
That's a little weird.
What is it? It is a little weird, but let's do 2 years. What's it worth 2 years?
0.90. 0.99.
No, not quite.
No? Oh, because it's 5% of 95 now.
Compounding, exactly. So
Yeah.
it's 0.95 of 0.95 X. The purpose of this problem was to show you this, that you can't just subtract 5% for every year.
Yeah.
What we're dealing with is a compounding depreciation or appreciation. And it works the same way either year. If you go to a bank and you get 5% interest on your money and it's compounded yearly, then the amount of interest you earn in the second year is not 5%, it's 5% times 1.05%.
Uh-huh. Let's try the next one, I guess.
All right, now we're getting some interesting creative problems that you have to think about. So the first term is minus 10. It's an arithmetic sequence, so this is actually pretty easy.
Yeah. It's
The next term.
-7.
And the third term.
-4.
And the fourth term.
-1.
That's what they asked for.
Yep.
Fourth term.
The other one is a little bit trickier, I think.
The eighth term of a geometric sequence where the second term is 400 and the fourth term is 9.
900. Doesn't it say 900?
It says 9 to me. Oh, second term is 900. Fourth term is 9.
Yeah.
Okay. Well, the most important thing here is to figure out, first of all, give me the general format for the nth term of a geometric sequence.
It equals the first term times the difference.
Times the ratio, not
Times the ratio. Or, yeah.
and it's the ratio to the n minus 1 power.
Yeah.
Okay? So, they told us that the eighth term, what is the eighth term? If the second term is 900 and the fourth term is 9, well, let's write out that. We got a first term, we got a second term, we got a third term, and we got a fourth term. What do you think the common ratio is? There's more sophisticated ways to solve it, but I like what they're doing here.
Is the first term 9,000?
Yeah, in other words, what's the common ratio?
10?
1/10.
1/10, I mean.
Not 10, but 1/10.
Yeah.
Which would make that 9,000, would make that 90.
And
now, my
the
nth term is equal to the first term times the common ratio to the n minus 1. Well, they want the eighth term, so that's the common ratio to the seventh power, right?
Yeah.
Okay. So, the eighth term is 9,000 times 1 over 10 to the seventh power. And what that means is 1 with 7 zeros. Like that.
And then you put it in your calculator?
No? Then you pull out 3 of those zeros and 3 of those zeros.
Oh, yeah.
What you have is 9 over 10,000.
Uh-huh. Okay, yeah.
And that's actually your answer. That is the eighth term. In other words, notice that it's getting smaller every time.
Yeah.
In fact, the fifth term is going to be 9/10. The next term is going to be 9/100. Then 9/1000. What's that? 1, 2, 3, 4, 5, 6, 7. The last term would be 9 over 10,000. That's what we got by using the formula.
I guess we could take a peek at the next page. So we got 3 minutes. We can do one maybe.
Okay.
So not too long.
Which problem?
Go back to the last
3
page.
minutes. We probably only have time for one problem.
Yeah, let's go to the last page. Let's just do, we do have the, what's it called? Let's do 18, I guess. Yeah, 18, if we can.
Yeah, evaluate. Okay, these are actually pretty easy.
Okay.
Is all you do is write out the series. Okay? That sigma sign means you're going to add every term in the series. The very first term is going to be where k equals 1. Well, what's the first term in my series if k equals 1?
1. Wait.
Plug in k equals 1 and figure out what you get.
-1.
Think -3.
-3?
No, hold on. No, you're right. -1. Sorry. I was misspelling the parentheses. What's the second term of the series?
What if k equals 2? Or...
Yeah. And what happens when k equals 2? What is that thing equal to?
2. Oh, wow. Okay. 1 is 3.
Adding those. The difference between a sequence and a series is that a series implies addition. A sequence is just a sequence of numbers. But a series always implies addition. So what's the term?
What's the, it's 3, okay, 2, 6, 5.
And they want you to evaluate that. Well, there's only 5 terms. We've listed the first 3. Let's do numbers 4 and 5.
4 is, 4, 8.
And 5?
5 is 11.
Add all those together. That's your answer.
And that's your answer? Okay, yeah, that's pretty easy.
So it's 18, 23, 25, 24. In other words, the way I should separate each term by a plus sign. Because when you see the sigma sign, that means a series where you're adding everything together.
It's time for your next session, Mr. Cowan. Don't want to keep them waiting.
Thanks, Dominic. I will talk to you on Wednesday.
On Wednesday?
Is that right?
I thought it was Thursday.
Hold on.
I took it today. I changed.
Normally we're on Tuesday and Thursday. Yes, you're right. We are next week is Thursday.
Yeah, I was going to see you Tuesday, but then I realized I have my test tomorrow, so I thought, why not just see you today instead of that?
Okay.
Okay.
So our next appointment is 4 o'clock my time on Thursday.
Yep. See you then.
Thanks. Talk to you later.
Have a good week.
You too.
Bye.
Bye.